Hey, Miss W here. I want to do some trigonometry word problems with you. So I'm going to look here for some examples in the directions, label the diagrams, set up the trig equations, and show you work round to the nearest integer or the nearest degree. Okay, so I'm looking for whole numbers here. So that is simple enough for the rules. So let's begin. So Mrs. Larry's cat is stuck in her backyard tree. A fireman positions a ladder against the tree branch and rescues the cat. The ladder was extended 22 feet and made an angle of 62 degrees with the ground. What is the cat's vertical height of the tree? So I'm going to start by labeling what I know. I know the ladder was extended 22 feet, so 22 feet. And it made an angle of 62 degrees with the ground, so 62 degrees. What is the cat's vertical height? Well, this is your vertical height, so I need to see what that is, and here's my kitty cat. So I label my O, A, and H. Across from the right angle is always your H. Put your pencil on the hypotenuse in the arc, trace it over, that's always your adjacent, and then your opposite. So I need to find x, so that's one of it. I don't have anything with a, but I've got h. So the trig function that uses o and h is sine. So I start with sine, the angle 62. Opposite is my x, and hypotenuse is 22. You solve this by multiplying 22 to both sides. And then you go ahead and put, well, first of all, you make sure your Desmos or whatever calculator you're using is in degree mode. Remember that. So degree mode, then you put that in, and you will get approximately, x is approximately 19 feet. So let's do another one. I'm going to erase that so it's not so cluttered. So let me do that. And then I'm going to read the next one, and we're going to go from there. So remember, you're sketching your diagram and you're labeling your sides and going from there. So from the top of a barn, a pigeon spies a pile of birdseed on the ground. The angle of depression of the seed is 38 degrees. The height of the barn is 28 feet. Find the distance from the pigeon to the seed. So I'm going to start labeling what I know. Okay, I know that the angle of depression is 38. So remember, the bird is looking down, so this is 38 degrees right here. And before I go any further, this is my transversal line right here. So this also has to be 38 degrees. Okay, so I've got that. I'm going to take that 38 away so we can see what we're doing better. So we got 38 degrees. Now, the height of the barn is 28 feet, so it's 28 feet here. Find the distance from the pigeon to the seed. Well, the pigeon's up here, the seed is down here, so I'd have to be talking about the hypotenuse. So then we go ahead and label our diagram. Remember, this is a right angle. So across from the right angle is my hypotenuse. Put my pencil on the hypotenuse in my arc, trace it over, gives me my adjacent. So that's my opposite. So now I look for the trig functions that has an O and an h in it, and again it is sine. So I would do sine 38, opposite is 28 over hypotenuse, which is x. And remember, this one you just have to do a little bit of algebra with. So I need to get rid of that x, so I'm going to multiply both sides by x. So I get x sine 38 equals 28. I need x by itself, so I divide both sides by sine 38, giving me x is approximately, rounding to the nearest degree, 45 feet. So pause this if you need it, otherwise I'm moving on. So I need to, I'm going to make more room. So I'm going to get rid of that and go ahead and start with the next one. So the third one on this page, again, I'm using my SOHCAHTOA there. I erased my sign over here. Shame on me. So this is sine. All right. So a tree casts a shadow 26 feet long. when the angle of elevation of the sun is 68 degrees. Find the height of the tree. All right, so shadow. Remember, if you're looking down, you see your shadow. It is always on the ground. It's not like standing up in the air at all. That doesn't really make sense there. So my shadow has to be 26 feet. Let me use a different color so you can see it better. 26 feet. There we go. The angle of elevation of the sun. Now you need to be careful because remember, this can't be the angle of elevation because the sun would be looking down then. So we have to do angle of elevation with the sun. Here it is, 68 degrees. Find the height of the tree. Well, I need to find X right there. So I start by labeling. Remember, this is a right angle. So across from the right angle is the hypotenuse. Put my pencil on my arc and the hypotenuse, trace it over, gives me my adjacent, leaving the X as my O. So then I look and find what trig function, hypotenuse does me no good, O and A. So looking at my trig functions, I can see TOA, or tangent. So I set this up, tangent 26, oops, sorry, 68. Tangent 68 equals opposite is my X, adjacent is my 26. So in solving this, my calculator's in degree mode. I multiply that out, and I get approximately, rounded to the nearest foot, 64 feet. So that tree is quite high. All right, I'm going to do 3 more, and then this video is done. All right, a plane takes off from LAX airport and ascends for a distance of 3,200 feet. The plane traveled 2,400 feet horizontally. Name the plane's angle of elevation at takeoff. So with that being said, I'm going to start by labeling. Now it says ascends for a distance of 32. The distance, if the plane starts here, you're really talking about the distance horizontally. So this is where your 3,200 goes. 24 feet horizontally. The plane is traveling horizontally, so that's 2,400 feet right there. And then it's asking for the angle of elevation. Well, angle of elevation is looking up, so this is my X right there. So now let's label my sides. Okay, across from the right angle is always my H. Put my pencil on the H in the arc, and this would have to be my adjacent, leaving this my O. So I'm going to use my H and my A, but I'm also finding a missing angle. So with that being said, remember you're going to use cosine -1, and that is going to equal, let's see, lost my train of thought. So opposite is 2,400 over 3,200, which X is approximately 41 degrees. So remember, you don't put the X in your calculator. You just press this key and you put 24 divided by 32 in there. 3,200, excuse me. Okay, so that's all you're doing there. One more, and then we will be done. So hopefully you can refer to this to help you out. So this one states, when attempting to stop at a stop sign on an icy road, Jerome slid through the intersection into a nearby 15-foot telephone pole. The angle of elevation of the telephone pole from the bottom of the stop sign is 70 degrees. How far did Jerome's car slide from the stop sign to the telephone pole? All right, so here I've got a 15-foot telephone pole. Here's my telephone pole, so there's 15 foot. It tells me the angle of elevation, so I have to be looking up, and it tells you from the bottom of the stop sign. So here's my stop sign. So this is my 70 degrees. And I want to know how far his car slid. His car, it's not sliding in a horizontal way unless, you know, it's like flipped in the air. But it's not, so it's sliding across here. So I need to find out X. So as always, I'm going to start labeling. This is also a right triangle here. Or right angle, excuse me. So this is my X. Put my pencil on, sorry, got ahead of myself. This is my H. Put my pencil on my H in the arc, trace it over. This is my A, leaving O over here. So what trig function uses A and O, and that would be tangent. So tangent 70 degrees equals opposite over x. So this one, you would also have to multiply both sides by x. And then you would have to go ahead and divide, like the Christmas colors. Christmas is coming. Anyway, so tangent 70. So again, in your calculator, you would make sure in your degree mode, you would put you would put 15 divided by tan 70, and you would get approximately 5 feet. So he slid about 5 feet. All right, I hope this helps.